20 Essential Apache Spark Optimization Techniques with Code. Welcome to today's video on Apache Spark Optimization Techniques. If you want to boost your Spark job's performance, you're in the right place. I'll walk you through 20 powerful tips and code examples to help you optimize your Spark applications. Let's dive right in. 1. Partitioning. Partitioning refers to dividing the data into smaller, manageable chunks, partitions, across the cluster's nodes. Proper partitioning ensures parallel processing and avoids data skew, leading to balanced workloads and improved performance. Repartitioning data frame to 10 partitions based on a column ndf_repartitioned equals df. Repartition 10, column name. 2. Caching and persistence. Caching and persistence are used to store intermediate results in memory, reducing the need for recomputation. This is particularly useful when the same data frame is accessed multiple times in a Spark job. Caching data frame in memory df. Cache, df, show, hash. Persisting data frame with a specific storage level, memory and disk, from py spark import storage level df, persist, storage level, memoryandddisk, df, show. 3. Broadcast. Broadcast variables allow the distribution of a read-only variable to all nodes in the cluster, which can be more efficient than shipping the variable with every task. This is particularly useful for small lookup tables. Broadcasting a variable broadcast var equals sc, broadcast, 1, 2, 3. 4. Avoiding shuffles. Shuffles are expensive operations that involve moving data across the cluster. Minimizing shuffles by using map-site combine or careful partitioning can significantly improve performance. Using map-site combine to reduce shuffleadd equals rdd.map, lambda x, x, 1, reduce by key, lambda x, y, x plus y. 5. Reduce task serialization overhead. Using Kryo serialization can reduce the overhead associated with task serialization, improving performance compared to the default Java serialization. Enabling Kryo serialization Spark, conference.set, Spark, serializer, org, Apache, Spark, serializer, Kryo serializer. 6. Columnar format. Using columnar storage formats like Parquet or awk can improve read performance by allowing Spark to read only the necessary columns. These formats also support efficient compression and encoding schemes. Saving data frame as parquetdf, write, Parquet, path, to, Parquet, file. 7. Predicate pushdown. Predicate pushdown allows Spark to filter data at the data source level before loading it into memory, reducing the amount of data transferred and improving performance. Reading data with predicate pushdown df equals Spark, read, Parquet, path, to, Parquet, file, filter, column underscore name greater than 100. 8. Vectorized UDFs. Vectorized UDFs, also known as pandas UDFs, utilize Apache Arrow to process batches of rows, improving performance compared to row-by-row processing in standard UDFs. From pyspark.sql, functions import pandas_udf, pandas UDF type at pandas_udf, double, pandas UDF type, scalar, def vectorized_udf, x, return x plus 1 df, with column, new_column, vectorized_udf, df, existing_column, show. 9. Coalesce, reduces the number of partitions in a data frame, which is more efficient than repartitioning when decreasing the number of partitions. Coalescing data frame to one partition df_coalesced equals df, coalesce, 1. 10. Avoid using explode. Explode is an expensive operation that flattens arrays into multiple rows. Using it should be minimized, or optimized by reducing the size of the data frame before exploding. Using explode function from pyspark.sql, functions import exploded f_exploded equals df, with column, exploded_column, explode, df, array_column. 11. Using data frames, datasets API. The data frames, datasets API provides higher-level abstractions and optimizations compared to RDDs, including Catalyst Optimizer for query planning and execution. Using data frames API df equals Spark, read.csv, path, to, csv, file, df equals df, group by, column underscore name, dot ug, value underscore column, sum. 12. Join optimization. Broadcast joins are more efficient than shuffle joins when one of the data frames is small, as the small data frame is broadcasted to all nodes, avoiding shuffles. Hash. Broadcast join from pyspark.sql, functions import broadcast df equals df1, join, broadcast, df2, df1, key, equals df2, key. 13. Resource allocation. Properly allocating resources such as executor memory and cores ensures optimal performance by matching the resource requirements of your Spark jobs. Resource allocation is typically done through Spark configurations when submitting jobs. Spark submit executor memory 4 grams executor cores to your _script.py. 14. Skew optimization. Handling skewed data can improve performance. Techniques like salting, adding a random key, can help distribute skewed data more evenly across partitions. Hash. Handling skewed data by salting from pyspark.sql, functions import randdf underscore salted equals df, with column, salt, rand. Asterisk 10, cast, int, df underscore salted underscore repartitioned equals df underscore salted, repartition, salt. 15. Speculative execution.re runs slow tasks in parallel and uses the result of the first completed task, helping to mitigate the impact of straggler tasks. Hash. Enabling speculative execution Spark, conference.set, Spark, speculation, true. 16. Adaptive query execution. AQE optimizes query execution plans dynamically based on runtime statistics, such as the actual size of data processed, leading to more efficient query execution. Hash. Enabling AQE Spark, conference.set, spark.sql, adaptive, enabled, true. 17. Dynamic partition pruning. Dynamic partition pruning improves the performance of join queries by dynamically pruning partitions at runtime, reducing the amount of data read. Hash. Enabling dynamic partition pruning Spark, conference.set, spark.sql, dynamic partition pruning, enabled, true. 18. Reduce shuffle partitions. By default, Spark has a high number of shuffle partitions, 200. Reducing this number can improve performance, especially for small datasets. Hash. Reducing shuffle partitions Spark, conference.set, spark.sql, shuffle, partitions, 50. 19. Leveraging built-in functions. Built-in functions are optimized for performance and should be preferred over custom UDFs, which can introduce significant overhead. Hash. Using built-in functions from pyspark.sql, functions import call, exprdf, select, call, column underscore name, alias, new underscore column underscore name, show. 20. Tungsten execution engine. Tungsten is Spark's in-memory computation engine that optimizes the execution plans for data frames and datasets, utilizing memory and CPU more efficiently. Tungsten is enabled by default in Spark, so no specific code is needed. However, using data frames and datasets ensures you leverage Tungsten's optimizations. That wraps up our list of essential Spark optimization techniques. Applying these strategies can significantly boost your job performance. Don't forget to like and subscribe for more tech content, and feel free to ask any questions in the comments. Thanks for watching.